And I'm going to open it in a hex editor so we can see what the file contains. It's obviously going to contain the image data, but if we it's not working now. Here we go. Now this is the image data for a PNG image. But you can see there's a comment just there. This is additional data added to the image, and this bit right the way here is the actual comment contents, the value if you like. Now if we copy and paste this and put it into a binary file, which I've done already, just the data. Now these equal sign at the end suggest that this data is encoded using something called base 64. So we're going to run this through a base 64 decoder on the command prompt. So base 64 minus decode image data dot base 64. And now we get some gobbledygook. Well, if we put this straight into a binary file and again run it through a hex editor and look at the contents, the thing that immediately sticks out is this 424242. This is what that algorithm was looking for when it was doing these sanity checks. Remember I said there's the 4141 check right at the end of the program, and then it's looking for 4242 right after the program. So that suggests we're along the right tracks here. So if we take this code here and put it at the end of the program, I've got one here which I've done already. So right at the end of the program here, this is the last bit of the program, there's the 4 ones, and then this here is just those bytes from that hex editor. All these bytes here I'll put right here at the end of the program here. That appears to complete this diagram now. We've got the main program code, we've got the data to be decrypted. As we run through the main program code, it's going to construct the key stream on the stack, it's going to copy this data then onto the stack, and then it's going to decrypt the data, leaving the decrypted data on the stack, and then it's going to get to what I've called my exit and just exit the program. It's not going to do anything. So let's just test the program works first of all. We're going to compile it using an assembler called NASM. And we're going to compile it in ALF mode, which is a Linux binary format, so we can actually run it. It's kind of like the exe of Linux. And then we just need to link it so we can actually run it. And now if I run the file, we see it does nothing. It doesn't crash. That's great. That means the code appears to be working, and it exits, which is what we expected, because the code, that's all it does. It runs through, the code runs through, and then it exits. It doesn't print anything out, doesn't display anything, doesn't appear to do anything else other than modify memory. So now there's two ways then. Once we've got to this point, the decrypted data appears to be in memory. So we've got to somehow extract this encrypted data. One way is to write some code in here which dumps the decrypted memory to the screen. The other way is to actually run the entire program through something called a debugger and ask the debugger to dump the memory. And that's what I'm going to do. I'm going to use a debugger called GDB. It's the free debugger for Linux. And we're going to ask it to run the program which we've just compiled. And then we know once we get to my exit in the program, once we get to this stage, the full decryption algorithm is run, and stored in the stack at this point should be the decrypted data. So we somehow need to stop the program here at this point and then dump to a file this part of the memory. And that's exactly what I'm going to do. I'm going to tell GDB to break the program, i.e. stop the program, at the my exit symbol. And I'm just going to run the program. The program has run the whole way through, and it's reached this point in the code here at my exit, and it's stopped. Now if I run info registers, this tells us the state of all these registers which we've been modifying throughout the program. Now if you study the decryption algorithm up here, you can see that the EDI register references the memory address at this point here. And in fact, once the decryption algorithm's run, it references this point here. So we need to get the value from the EDI register and then subtract the number of bytes which have been decrypted and then dump that to a file. So there's the EDI register just there. So let's copy and paste that. And I'm going to say dump binary memory to the file out, starting at address 29C. Well, that's the end, so we need to take something away from here, so I'm just going to put 50, and then finishing at the address 9C, and dump that. If we look in our directory, there should be a file called out. Let's open with the hex editor, and you see here's the start of the decrypted data right up to here. So this is the decrypted data. Now those of you who've done networking or anything like that will recognise that this is the first line of a web request, a HTTP request, and it appears to be requesting a file from somewhere, we don't know where, but obviously we're going to theorise that it's from this website here. So if we copy and paste the web address and put it into Chrome at the end of here, rid of the first slash, and press enter. Now we press enter, we'll find out whether this file actually exists. And lo and behold, this is stage 2 of the assignment, which I'll solve in the next video.